Hi everyone and welcome back once again.
So in the previous lecture, I discussed about the calibration of ultrasonic transducers using the IIW block.
Yeah, so at this point I thought if I show you a video of this calibration process that you saw using the IIW block, it will give you a first-hand idea, some practical knowledge about how exactly the ultrasonic testing is done and how the calibration is done, right? So while doing the calibration, you would also get a feel about the process as to how the ultrasonic signal will look like when you are actually examining a part for identifying defects. Okay, so let me show you that video that we have captured in our lab, in the NDT lab that we have in our department. All right, so as I said, this is a very versatile calibration block because here you can also calibrate the distance if you want apart from the angles that we discussed. So here you can see the thickness of the block in this particular video which I have paused right now. So here you can see the thickness is 25 mm. That's the thickness of the block. Okay. And using that thickness, you would also be able to calibrate the x-axis of the display. That is the time base, right? Because if you just get a signal from this thickness, then it should come at 25 mm on the display, right? So if it is coming right at 25 mm, then you know that your transducer is calibrated, right? And if it does not arrive at the 25 mm depth, right, when you see it on this x-axis, then you need to do the adjustments to bring it back to 25 mm, and that's how you can calibrate the transducer in terms of the depth or distance, right? So this is what is shown over here right now, that this particular transducer is being calibrated for the depth using this 25 mm thickness of the block, right? Can you see this? I have put a marker over here, this white color thing that you see over this peak, right? So this marker will indicate the distance over here on this particular window, right? So you can see it is about 26.8 mm, right? So it is a little bit different from 25 mm. This should have come at 25. So some difference is there, and this has to be adjusted to bring it back to 25 mm. There are certain controls here. Using those controls, this has to be brought back to 25 mm. And then you would know that your transducer is calibrated for the depth. Okay. This big peak over here that you see, that's the initial pulse. Okay. And rest of the things are all the back wall pulses, the back wall signal that you see coming out from the thickness of this block. So this is the first back wall, which is supposed to come at 25 mm. Then this is the second back wall, which will come at 50 mm. This is the third back wall, which will come at 75 mm. So generally what you do, we do not really have to use this higher order back wall signals. We can simply discard them by adjusting the x-axis so that you only have the initial pulse and the first back wall pulse. That is how the display would be generally when you do the examination, right? So anything which will come in between this initial pulse and this back wall signal will be taken as a defect. Here you can see a small echo, but this is probably a noise. This is not really any defect signal. So this noise is there, which you need to take care again by calibrating the transducer so that this can be eliminated when you actually do the examination. This is again showing the second back wall, which is supposed to come at 50 mm. It is very close to that. So the transducer is more or less calibrated here. There is nothing significant difference. Yeah, so with little bit of adjustment that we did, now it is coming very close to 50, right? So now you can say that your transducer, this is basically a normal probe that we are using right now. This is not the angle probe. So the normal probe now is calibrated in terms of the depth because we are using the 25 mm thickness here, and for the second back wall it is supposed to come at 50, and that's what you see over here, right? What will be the third one? If I bring this marker to the third peak, yes, you would have guessed it right. This will be 75 mm. And you can see this is very close to 75 mm. So like that, we can check the transducer for the depth calibration. Now we are going to use an angle probe, an angle transducer, and see how it is calibrated in terms of the angle and the beam spread and so on, what we discussed. So you can see the angles which are marked on this surface of the block, and with the help of this scale, you can find out the beam angle and the beam spread as well. So let us see how that is done. And this is on the other side. So here you can see the angles are a little larger, as I said before. So if you have anything which is 60° or more, then this particular surface has to be used. And for angles which are less than 60° or within 60°, the other side is used. Yeah, so this is an angle probe which we are moving right now just to show you, marking the index point using the 100 mm diameter curvature. So right now we are trying to look at the index point first. As I said, that is the first step in calibrating the angle transducers. First you locate the beam exit point or the index point. So that is what is being done right now. This is an angle probe that we have here with a particular angle that the beam will exit at. So right now we'll get a maximum signal from this curvature that we have by keeping the probe on this surface. So let us try and see at what point the maximum signal is coming out. Yeah, so it is at this point when the signal is maximum, as you could see, right? So that's the index point which you need to first mark. Yeah, so we are going to mark the index point, as you could see over here now. Now we are going to do the angle calibration, what we discussed today. So it is being moved on this surface to find out where the maximum is coming. So let me go over this once more, the angle calibration part. So right now we are trying to find out at what point it is becoming maximum. And at that point you see the angle by matching the index point with the scale that you have on the block. So that will give you the beam angle. So that is what is being done right now. Right, so this is what we have found, that at this particular angle, it is giving a maximum signal. So this is, I suppose, this is a 45-degree angle probe. So when we bring the index point close to the 45-degree mark, you will get a maximum signal on the display. Same will go for other angles as well. Now we are going to find the beam spread. So as I said, you need to move the transducer on both the sides, on either side, till the time this signal that you have becomes 0. And once it becomes 0, you read the angle from this scale again. And from that, you will get the beam spread. So now let us move it on one side, on this side, and see where it is becoming 0. Yeah, so it was almost 0 around here, around I think 60-degree or so. Around 55-degree, right? That is where it is coming close to 0. Now let us move on the other side. And that side also, when it is close to 35 degree, little more than 35 degrees, then it is becoming 0. So 10-degree on either side, as you could see, right? So that's the kind of beam spread that you have for this particular transducer. And now you can see what is the distance here that we are going to calibrate the angle probe for. So from this end to the top of this surface, what is the distance? It is around 150 mm, as you could see. And you can see this value over here, right? This is close to the distance that I showed you. That was close to 150, so the same can be seen over here. So it also tells you that the probe is good in terms of the distance as well. Okay. This we have already seen the distance calibration with the help of this IIW block. But one very important thing that we discussed today was about the resolution, right? To find out whether the probe is capable enough to distinguish between closely spaced defects. And that is what I am going to show you in this video also, as to how you do that using that 2 mm notch what you have over here. Okay. So this is the notch you could see on this this end over here. So in order to get a signal from this notch, your probe will be kept on this surface on the other side, right? So this is the transducer probe, and it is moved over this notch so that you can get a signal from this notch from different points within this 2 mm distance. Okay, and let us try and see whether this transducer is showing up these 3 distinct echoes that you would get, one from this end, from this edge of the notch, one from the base of the notch, and another from the other side. Okay. If you get this these 3 distinctly, then it will tell you that the resolution of the transducer is good. We are also looking at the distance, because that is where it should come for each of these locations that I told you. So at what depth it should come, and that is what we are measuring right now. So we measured 3 depths, and we are looking for 3 distinct echoes here corresponding to those 3 depths. Right, let us see if we have 3 distinct echoes coming out from 3 different distances or depths. One of them, if you have noticed, was 85 mm, the first one, that is close to the base of the notch, and that is what is coming here. You could see it is at 85 mm. That's the first one, as you could see from here, right? Second one would be 91, as you would have seen while I was drawing the diagram and giving you the dimensions. So we had seen these two are 6 mm apart. One was 85 mm, and then just above it, around the notch, it was 91 mm, right? So you could see that. So we have 2 distinct echoes coming out from this notch, and then see the next one also, which is the entire height of the block, which is 100 mm, that you could see over here. So 3 closely spaced reflectors in terms of this notch and the thickness of the block are giving you 3 distinct peaks, right? And these are clearly distinguished. You can clearly distinguish them on the display. There is no overlap, although they are very closely spaced to each other, right? So this tells you that the transducer that we have used over here is a good one in terms of the resolution. Okay. All right, so that is how the IIW block is used for calibrating different kinds of transducers, both normal probe as well as angle probe. And as you could see, it is quite versatile for calibrating different aspects of ultrasonic transducers.